Surds are irrational numbers expressed in radical forms. That means in form of square root of a number, where this number cannot be expressed as an integer. Is that clear? Where x is not a perfect square. Perfect square are those numbers whose square root is the whole number. Now when we talk of surds, we are talking of numbers whose square root are not whole numbers. Square root of 3, for example, 3 is not a perfect square. Square root of 3 is a surd because the square root of 3 is not a whole number. So when we talk of 4, square root of 4 is what? This is a whole number. When we talk of surd, 4, we don't consider it as a surd because from the definition we say surds are irrational numbers expressed in radical form. So this number is not irrational. This is rational because this 2 over 1. But this 3 is irrational. It can only be represented in this radical form. Aside this, what you can get is an approximation. So 2, for example, this is in a radical form. Aside being so 2, what you can get is that it is approximately equal to 1.41 something. You can't exhaust it. If you say you should continue to write it, you keep on writing it to infinity. So that's why it's called a surd. There's a way surds are added. There's a rule that governs how surds are being multiplied. There's a rule that governs how two surds are being divided. Those rules are what we call the rules or the laws of surd operation. Number 1, if you have a surd x plus b surd x, so that this is equal to a plus b surd x. Is that clear? So even if it is subtraction, if you have it as a minus, you have it as what? Minus. Why is this possible? Because they have what? Common surd. They have common surd. You can easily, this is the coefficient of the surd. This a means general case. A is any real number. Is that clear? B is also any real number. So this is how you add them. Since the surds are common. Then you have a surd x plus b surd y is not equal to this. Why? Because these two, they are different. So this thing is already in this simplest form. Understood? Okay. The next one, then we have a surd x plus a surd y. This is equals to surd x plus surd y multiplied by what? A. See the similarities and the difference here. The same thing applies to minus. If here is minus a surd x minus a surd y, you will see be this way: a bracket just this same way. The next one we have, see what this one is saying. Then the first one, let me just leave them. So this one is saying if you have a quotient that is square root of a rational number, let's say 3 over 5. The same thing as saying square root of 3 over square root of 5. That means you distribute the square root for both the numerator and the denominator. Then this one, you say if you have x times y, that means the two numbers are multiplying each other, and you are taking the surd of those multiple. The same thing as saying surd x multiplied by surd y. Now this operation, the first use is that when you have square root of a number, you want to simplify it, you have to apply some of these rules so that you bring it to its simplest form, and that is the idea. When you are given an expression like this, the first thing you should look at is how do you write them in terms of common surd this way. But if you look at these two numbers, they are not in their simplest form. It tells you that there is a way you can break the number down using some of these rules. 72 is a multiple of something. Now what you should be looking at is a perfect square. How you can get a perfect square out of this thing so that you write it in terms of the simplest form. 72 is a multiple of something. Something multiply another thing to give you 72. So what we'll be checking is that what is that perfect square that multiply another number that's not a perfect square to give me these numbers here. So for this first case, you see that 36 is a perfect square, right? 36 times 2 will give you what? 36 times 2 will give you 72. Is that not? Plus 25 times 2. You see that you have achieved this thing using this first rule. This rule here, you have achieved this. You have written this surd as this product, right? So you go further. What does this thing say? So that when you have two numbers multiplying each other, it can be written as what? If it's inside SURD, it can be written as what? Separate SURD multiplying each other. Is that not? So you go further and say SURD 36 times SURD 2 plus SURD 25 times SURD 2. Is that clear? But you see that this one is not a SURD by definition. Why? Because the perfect square, product of the perfect square is rational. Abi, so when we express it, what do we have? 6 root 2. So I've written this SURD in a simple form this way. Plus 5 SURD 2. So now using this rule here, what does it say? This will be 6 plus 5. Abi? So having 6 plus 5 root 2, which is what? 11 root 2. So we have simplified this into this form. So this is just how to simplify SURD. So here was 108. 36 times 3 minus this one is what? 25 times 3 plus 9 times 3. So this one will give us what? Plus sub 9. So what do we have here? 6 or 3 minus 5 or 3 plus 4 to 3. Okay, thank you very much. So if we have SURD x now, the conjugate of SURD x is that SURD that will be multiplied to SURD x to make it what? Rational. When you multiply this, what do you have? X. These are irrational, but this one is what? Rational. Is that clear? The conjugate of a SURD is always unique. This is what forms the third rock of rationalization of SURD. So if you have an expression like this expression is not written in standard mathematical notation. You rationalize it by multiplying it by what? 1. This expression here is 1. That's why what you get afterwards is equal to this. Is that clear? When you multiply something by 1, what do you get? That same thing. X times 1 is what? X. 3 times 1 is what? 3. 3 over root 2 times 1 is what? So now, but our idea of multiplying it by 1 is so that we make it what? In the standard mathematical notation. Is that clear? So when we multiply this, what do we have? 3 root 2 over what? 2. So this is now written in the standard format. So from this case now, what's the conjugate of A? What's the conjugate of this from this definition? Root A minus root B is the conjugate. So when we have root A plus root B, you just see by yourself. Multiply by root A minus root B. Now this idea of conjugate comes from difference of two squares. So when we multiply these two numbers, what do we have? Root A times A is what? This times this will give us A, right? This times this will give us what? This times this will give us what? Then this times this will give us what? So that this will take away this, so we are left with what? A minus B. So that number that will multiply this to give us something rational is what we call the conjugate. Is that clear? Let's solve this question. What does this thing mean? This is trying to tell us that we should what? Rationalize. What is rationalize? Multiply by 1. But that one will get it from the what? Conjugate of the denominator. This is what we are given. So multiply by the conjugate is what? Plus. Remember I'm multiplying by 1. So what do we now have? 1 multiplied which we have SURD 3 plus SURD 2 over this is where the work is now. This time this will give us what? This time this will give us what? Plus root 6. This time this will give us what? Minus root 6. This time this will give us what? Minus 2. So from this we now have root 3 plus root 2 over 1, this will take away this, so we're having root 3 plus root 2. So just try this out, simplify this. So this one is say there's no rule that say it must be, all of them must be the same, no. So here we have 6 root 2 plus 3 root 2 over 12 root 2 plus 2 root 3. So this is what we have. So from there we have to evaluate 6 root 2 plus 3 root 2 over 12 root 2 plus 2 root 3. So we multiply by the conjugate of the denominator. So having 12 root 2 plus 2 root 3 over, no sorry, conjugate here with negative, 12 root 2 minus 2 root 3. And what do we have? 6 times 12 is what? 6 times 12 is what? 72, abi? Root 2 times 2 is what? 6 root 2 times 2 root 3 is what? Minus 12 root 6, abi? 3 root 2 times 12 root 6 is what? 36 times 2, abi? 3 root 2 times 2 root 3 is what? Minus 6 root what? 6 over, when you have a square, a plus b, a minus b, this is difference of 2 square, right? Abi? This is equal to a square what minus b square. So what does this imply? This times this minus this times this. When we multiply out everything, see that you see that those one in the center that will cancel out is what cancelled out here. So but I'm going to multiply everything out so that you see how they cancel. So 12 root 2 times 12 root 2 give us 144 times 2. 12 root 2 times this one give us what? Minus 24 root 6. Is that not? Yes. 2 times 12 root 2, the same thing give us plus 24 root 6. Then 2 root 3 times 2 root 3 will give us what? So we go over to express them properly. So here we have what? 144. We are collecting license now. Plus 72. This one is what? Minus 12 root 6 minus 6 root 6 over 288 minus what? 12. So what do you have here? 216 minus 18 root 6 over, this will give us what? 276. So to evaluate this, you have to express this whole thing. So have 3 root 18 minus 2 root 8 equals x root y. We have to find something. So we express this thing and compare it to this other side. Exactly. We solve this by comparison. So here we have 3 root 9 times 2, right? Minus 2 root 4 times 2. So this will be what? 3 times 3 root 2, abi? Minus 2 so this will give us what? 4 root 2. So this will be what? 9 minus 4 root 2. Now this is where most people fail it. This 5 root 2, abi. Now if you have to compare this thing now, you have that x is equal to what? Okay, let me write by comparison. X is equal to what? 5, and y is equal to not root 2 but 2. Y is equal to 2. Now let's find x squared minus y. X squared is what? Is equal to 5 squared minus what? 2. 5 squared is what? Then this, okay, evaluate this. We have 1 over root 24 plus 3 over root 54. So what do you have here? What of 6 times 4? 6 times 4 is what? Is 8 a perfect square? Is 3 a perfect square? So you go with a multiple of a perfect square. Is that clear? So 4 times 6 will give us what? Plus 3 over 54 is what? 9 times what? Right? So we say that this is equal to x root y. So if we evaluate this, what do you have? 1 over 2 root 6, abi? Plus 3 over what? 3 root. Is that not? Abi? So have that 1 over 2 root 6 plus 1 over root 6 is equal to what? X root y. So we can find the LCM here easily, right? When we take the LCM of this thing, what do we have? 2 root 6, right? Now 2 root 6 divided 2 root 6 is what? 1 times 1 is what? 1 plus 2 root 6 divided this one is what? 2 times 1 is what? We say that this thing is equal to what? No, x, let's just say x root y. Abi? So this thing will be what? 3 over 2 root 6. From this point we can rationalize. Is that not? By multiplying by what? Root 6 over root 6. I did not multiply by 2. Why? It's of no use. Is that clear? What we after is the irrational number. That is the solve. You have a question? Okay. So that this is equal to what? X root y. So if we multiply this out, we have what? 3 root 6 over 2 times what? 6 is equal to x root y. 3 divided by 6 is what? This will have 2 here. So having root 6 over 4 is equal to x root y. Now if you compare this thing now, let me write it very well. By comparison, x is what? 1 over 4. Y equals to 6. So for us to get this, we have that y squared. Therefore, y squared plus x is what? C squared plus 1 over 4. Which is what? 36 plus 1 over 4. 36 plus 1 over 4 is what? 145 over 4. And this is the final answer. If x equal to this and y equals to this, find this. X squared is what? So we'll break this guy down as well. So this is what we got as x, right? This is our x, is that not? So but we are looking for x squared. Y is what? 3 plus root 125. And this is equal to 3 plus what? 25 times 5. Abi? So these are our y. So x squared plus y is equal to what? What's our x? 3 root 3 minus 5 minus root 5 squared plus 3 plus 5 root 5. If we open this, we have 3 root 3 minus root 5 multiplied by 3 root 3 minus root 5, right? Then plus 3 plus 5 root 5. So you have to expand this guy just the same way we did multiplication in SURDS. So this times this will give us what? 9 times 3, right? This times this will give us what? Minus 3 root 15. So we are done with this one. So this times this will give us what? Minus 3 root 15. This times this will give us what? Plus 5. Is that clear? We are done with this one. So plus 3 plus 5 root 5. Okay, let's open this. 9 times 3 is what? 27. This times this will give us what? Okay, no, plus. Give us minus 6 root 15. Right? Then this one will give us what? Plus 8. Then plus 5 root 5. So let's finish it up here. So this and this, they are like terms. So we collect, what do we have? 35 minus 6 root 15 plus 5 root 5. So this is the final answer. Thanks for watching.